Big picture, we are multiplying binomials. Binomials are polynomials with how many terms? 2, right? So we're multiplying polynomials with 2 terms. How do I know we're multiplying? Well, what happens when I see you, Andrew Swanson, I'm coming, hold on. What happens when you have 2 things in math written next to each other, separated by parentheses? Isn't that always multiplication, right? Why is this one multiplication? I don't see multiplication. I see a squared, some people might say. Why is this one multiplication? Oh, freshmen, you just did it yesterday, and sophomores, you already forgot? How is this multiplication?
A plus B, A plus B.
Yeah, we could rewrite it. Thanks, Adrian. We could make it A plus B times A plus B. It's just a shortcut notation for multiplication, yeah? Okay. Now, we have 2 different shortcuts. We have squared minus squared, squared minus squared, or we have squared double squared. We have squared minus squared. It's called difference of squares. We have squared minus squared, or we have squared double squared. 3 terms. Who's who? What's this guy's answer when we multiply? Who is he? Squared minus squared or squared double squared? Squared minus squared. And what does squared minus squared actually mean? What does squared minus squared actually mean? My graph table people, I don't know why we call it graphs, but that's okay. Do you guys call, I don't know. I was going to go to biology for a second, but that's all right. We'll come back. I don't think you call it graphs in biology either, but that's all right.
So you call them by this.
But yeah, not graphs though, right? So they're tables. They have rows and columns, right? But if we were to do A plus B times A minus B, if we were to have A with a positive and A with a negative, we would get A squared minus B squared plus AB minus AB. What's always going to happen to these 2 whenever the original problem looks like this? Same, opposite sides, same. What's going to happen? They cancel out. And when they cancel out, what do we get? A squared minus B squared. You see squared minus squared? What then did that mean for homework? You guys pop over and peek at homework. Didn't we have a lot of these in numbers 15 through 22? Actually, weren't all of them? Weren't all of them differences of squares? Weren't all of them addition and subtraction and the terms actually match? So help me out. If you were to look at these, and maybe it's a little bit too small for some of you, let me zoom in. You can go peek at, I guess so. This was the homework from 2 nights ago, though.
Oh, yeah.
The one that you should have already done. The one that you should be able to go look at in your homework spiral. I'm going to grade it in just about 2 minutes. No, 3 through 10 was from like 3 nights ago. I already walked around, I already graded that one. This is the one that was from Tuesday night. 15 through 22. I think it's still on the board so that I can look at it today. 15 through 22, 25 through 27, 31, 39 through 40.
What? Oh, no, not that one. The new stuff.
Oh, you mean the board,
Yeah.
Andrew. Yeah, I need a picture of the board. That's okay. That's okay. I thought you meant a picture of this. And I was like, I don't think you need this. We already did it. All right, I'm going to call out your name, and let's see if you can do squared minus squared. That's all we have to do, squared minus squared. So, Melanie, what was number 15? Oh, yeah, you guys can turn to your homework. You don't have to do this one. Okay, do you guys see the squared minus squared pattern? She just said t squared minus 49, and she was totally right. Isn't this t squared and 49 and a minus in between, squared minus squared? Right?
Yeah.
Trey, what's number 16? Remember from yesterday?
6. So, n squared minus 36.
Got it. Uh-oh. Oh, wait, translate. Sorry.
Oh, God.
But yeah, you got it.
There we go.
All right, sophomores, you can be grading your evens because that's the first even. Squared minus squared. Squared minus squared. So, Adrian, what's number 17? Yeah, now, my people that were messing up the 3x times 3x is 9x squared a couple days ago. 4x times 4x is 16x squared, right? Squared minus squared. It's not bad. Squared minus squared. Squared minus squared. Isaiah, what's number 18?
What was it? 4k squared was minus 16.
Minus. Good. Thanks, bud. 4k squared minus 16. Check your next even, my sophomores. That was number 18. Did you get it right? 2k times 2k is 4k squared. Squared minus squared. Number 19. Levi, got it? What is it?
64 minus 9a squared.
Not 6, right? 3 times 3 is 9. Right, Andrew?
Yeah.
Stop with the extra words, please. 3 times 3 is 9. That was the one that you kind of messed up the other day. Remember the 6? Or other people, like, they accidentally said 3 again. 3i times 3a is 9a squared. So 64 squared minus 9a squared. Squared minus squared. Now, yesterday, my freshmen helped the sophomores out. Not that they didn't get it right, but we talked about it yesterday. We didn't like, or you didn't like number 20 because of the fractions, right? But Alexis, do you remember what we did and how we got it? What was number 20?
The answer?
Yeah.
It was 1/2 minus c, and then 1/2 plus c.
Good, that was the problem. And then do you remember what happened when we multiplied? It was squared minus squared. No. I got it. Yeah, Andrew.
Negative c squared plus 1/4.
Okay, that's one way. But can I write it 1/4 minus c squared just to make it look nicer? Isn't it squared minus squared? What's 1/2 times 1/2? That's what was hard yesterday. 1/2 times 1/2. Oh, well, 1/2 times 1/2 is 1.
Double half.
1/4. You were thinking, Andrew, I think you're thinking doubling by like adding. If you have 2 halves, then you have double, I guess. But if you're just multiplying 1/2 times 1/2, that's when we just multiply tops and bottoms. Got him, 1/4. So I know even fractions can be squared. They're not as nice, they're not as pretty, but square the fraction. 1/2 times 1/2 is 1/4. Squared minus squared. Okay, number 21. Number 21. Adrian, you want to take it away? What do you got?
Q squared minus
Q squared. Got it. Squared minus squared. The P gets squared and the 10Q gets squared. Number 22. It's getting a little bit harder as we go. But I'm going to go ahead and, just because it's starting to get a little bit hard, my sophomores, you're trying to grade, let me keep going. But squared minus squared. 7 times 7, 49, n times n squared. 8 times 8, 64, n times n squared. Negative y is y squared minus 4 and 4 is 16. And even these ones, a negative times a negative is a positive, 25g squared minus 4h squared. All right, check them. You guys can check. 16, 18, 20, 22, 24. Sophomores, if you have not yet. Freshmen, we did it yesterday, but that's not where homework stopped. We kept going to 25 to 27. Squared minus squared. And in 25 to 27, these were the funny. They were kind of weird, to be honest. Let's do things with numbers. I'm not going to spend a lot of time on this because this isn't going to show up on a quiz necessarily unless it's a bonus. Oh, hey, tomorrow's what?
Half day.
It is. But it's also Friday, and Friday is our homework quiz day. Now, we didn't have one last week. We weren't here on Friday. So we're going to have a homework. All right. Remember, we distract each other, and then we don't get stuff done. So tomorrow is a half day. True. Alyssa, tomorrow is a half day. That's true, but it's also our homework quiz day. Okay, so that's why we may be going over questions today, making sure we're okay. It's our homework quiz day. Now, sadly, since we didn't have last week, we didn't have 7-1 or 7-2 last week, we kind of have to do 7-1, 2, and 3 this week. But that's okay. Next week, before our test, we have a test next Thursday, I think. We're going to have another chance to take another version of it, just like we always do. But these aren't going to show up as normal problems on a test or on a quiz. They're going to show up as extra credit. They're just mental math tricks. And can any freshmen explain to me how we did this yesterday? What were we looking for in order to rewrite these mental math problems? Because I asked them, I was like, hey, something to the effect of, Joseph, do you know what 16 times 24 is off the top of your head? And all of them were like, no. Most people don't. 16 times 24,
Nah.
24. Off top of your head. Where's my calculator? Where's my, right? But even though this mental math is hard for most people, we realized that we could actually rewrite it, and in rewriting it, use our special patterns in order to solve it. Now, who's going to explain it to me? Someone who's ready. Levi. What did we do to rewrite this?
We added 4.
Yeah,
Find the middle.
find the middle. That was the key. Good. Find the middle. What's the middle of 16 and 24? 20. You have to subtract 4 to get to 16, and from 20 you have to add 4 to get to 24. 20's in the middle. Oh my goodness! It's a squared minus squared pattern. Now, a few of the kids yesterday were like, how on earth did you do this mental math? But it's because I know 2 times 2 is 4, so 20 times 20 is 400. 2 times 2 is 4, so 20 times 20 is 400. And then you were able to do 4 times 4 is 16. Now, this is kind of hard, but this subtraction is easier for most of you to do in your head than this multiplication to do in your head. So the shortcut rule for 16 times 24 is find the middle number and then use our squared minus squared shortcut to say, oh, this is 384. Dun, 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 dun. That wasn't as bad as it got. Maybe. Huh? Yeah, nicely done. So, what's the middle? Jerry, let's see if we can do this one. Do you have 33 times 27? Ah, you're looking though. That doesn't count.
No.
Okay, but see what I mean? See what I mean? Fine. But what's the middle of 33 and 27? No, that's okay. Can you find the middle number? The middle number of this guy is 20 because it's up 4, down 4. 30, yeah, good. So this would be 30 plus 3. 27 is 30 minus 3. Adrian, what's 30 times 30? 900. Squared minus, what's 3 times 3? Everybody. 9. So, Jerry, check it. Is it 891?
Yeah.
Got it. Squared minus squared. We can be amazing and do some crazy multiplication that maybe you didn't know you could. Now, hold on. Do you remember in our opener, weren't there 2 different shortcuts? Weren't there 2 different types in this section? The most recent homework just looked at squared minus squared up until number 27. Number 27 actually had us looking back at where numbers 3 through 10, the beginning of homework from a few days ago started. Because this one, oh, let's go back to the book. This one isn't a squared minus squared. This one isn't a middle number. This one is a, well, let's go to who's easier, which is 40. And we have to do it twice because squared means multiplication, right? Okay, let's pause and say, wait a minute, what's this shortcut then? It's not squared minus squared. That's with these ones, 1 plus 1 minus, 1 plus 1 minus. Guys, what's the other shortcut? This one's harder. There are 3 pieces. Squared, fine. What's the graph saying thing? Plus double, plus square. Yeah, you guys probably listened to all the videos yesterday, right? Squared minus squared. That's this guy. Squared double squared is that guy. Squared minus squared. Squared double squared. What do I mean? What if we were to make a table for this guy?
Negative x squared plus 4. But it might be 4 minus 1 x squared.
Well, let's make a table for this guy. Adrian, you were the one that noticed that these ones canceled out, right? Oh, that wasn't Adrian. Sorry, Jonathan, you noticed it. That these 2 canceled out. You might have. But Jonathan said it out loud. That these 2 canceled out. That's why we have squared minus squared over here. But when we go to our table on this guy, does AB plus AB equal 0? Does that cancel out this time? Instead, what does it do? It combines. So you have squared. How many of these do you have? 2. Double. Squared. Squared minus squared or squared double squared? Squared minus squared or squared double squared? So what kind of pattern, guys, will this one No.
It's just, I thought it was just a
Well, you could just do 42 times 42, but that's hard mental math. We have squared minus squared, squared minus squared. We did tons of squared minus squared. What's the harder pattern with 3? Squared.
16.
No, close. There's 3. So squared plus squared. What's in the middle? Squared. Double. Squared.
1600 plus
Yeah?
160.
So Alyssa, you got it? What are the 3s? We have squared. Help her out. Help her out. Squared. Double. Squared. Melanie got it. Alexis, what's the pattern? Squared.
Squared. Double.
Double.
Squared.
Squared. That's right. So what is it? Squared.
Double.
Double. Squared. So then Diana, squared. Double. Squared. So everybody, what's the pattern? Squared.
Double. Squared.
Okay, wait, one more time. That was kind of sloppy. Squared. Okay. So squared minus squared or squared double squared. So squared, what's 40 times 40? Ooh, anybody amazing? Times. 4 times
1600.
1600. Squared. Double. Double what? No. No, double. Let's go back and look at our shortcut. Hold on. We're supposed to square it, and then we're supposed to double these guys. Double, oh! Double the multiply. Come back. What's 2 times 40?
80.
80. But we got to double it.
1600.
Close. Too many. 80 plus 80, or 2 times 80 is 160. Not 60. 160. Squared. Double the 80. Squared. 1764. Dun, 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 dun. Woo! No calculator necessary. No calculator necessary. Okay, but once again, these are more like bonuses than anything else. Alright guys, can we just make sure we have squared, double squared? So what does that mean number 3 was a long time ago? If it's squared, double squared. What's the square root of x?
Squared.
X squared. What's the double of 8x?
16.
Double. 16x. And then what's the square of 8? 64. What? No table necessary? You guys helping out? Or at least a couple of you are. How about the rest of you? Come on. Squared, double squared. What's the square of A?
Yeah, squared.
What's the double of 6A?
36.
Double. 2 times.
12.
12A. But wait, is it going to be a plus or a minus? Good. And then squared. What's negative 6, negative 6?
36.
Jeremy, can you do this on that?
Oh.
Are you seeing the pattern? Check it. Squared. Got him. Double. 2 times 8 is 16x squared. Squared. 8 squared. Double. 2 times 6 is 12. But negative. Negative 12a squared. How's it get a little bit harder? Let's do it number 6. Keep it a little bit easier. What's the square root of 5p?
5p squared.
25. Careful. 5 times 5. See it? Got a little harder. Double. What's the double of 10p? Double. Times 20p. You see it?
20p.
And then squared. Now, pause. If some of you are like, you're losing me, the shortcut's losing me, that's okay. What can you always fall back on for any of these? Get to your table and say, nah, I know how to do this. Get to your table and say, nope, I know how to do this. If this shortcut ever doesn't work, no big deal. Get to your table and say 25p squared plus 20p plus 4 and get it that way. All right. Band of homework, my kiddos who were here yesterday. It was number 31 and 39 and 40.
It's 31. That's
No.
Why was 31 wrong? Now, freshmen, shh, sophomores, you tell me from your homework that you're grading. Why was 31 wrong?
I have no clue.
What?
Because they didn't have a, so you know how it's x squared, x1, and y squared. They didn't have a middle.
Did you guys hear Isaiah? My freshmen, I told you to be silent. Thanks for disobeying me. Be silent. My sophomores, you're looking and trying to grade number 31 to find a mistake. Which case, which shortcut? Check it. Which one is number 31? What should it be?
A plus b squared.
A plus b squared. So how many terms should be in the answer? 2 or 3?
3.
Yep, it's squared, double squared, right?
Yeah.
So check it. Squared, got him. Double, don't got him. So they messed up the shortcut. They did the wrong one. They did squared and squared. No way, Jose. Adrian, focus. Thank you. What should it be? Guys, come on. We just did a lot of these. What's squared?
36.
No, start here. Start here.
K squared.
K squared. What's double? 8K. You see it? You see it? 8K. And then what's squared? 4 times 4 is
16.
Now pause. Did you need to be doing the shortcut anyway? No. Wouldn't it have been K squared plus 4K plus 4K plus 16? Wouldn't it have been K squared plus 8K plus 16 anyway? No matter how you do it, they messed up. They did not have, Isaiah said it, the middle. They didn't have the double. They didn't have the outer plus the inner. All right. Sophomores yesterday said 39 and 40 were pretty easy, and so we didn't have to spend a lot of time on that. We're going to peek real fast. And I think it's on the next page, isn't it?
Yeah.
No, these weren't easy. These were nasty hard. Well, were they? What's the shortcut?
4 plus 1.
Squared minus squared. Yeah. X squared times x squared is x to the power of, did you guys figure out the exponent? 4? Minus 1 times 1. Squared minus squared. Squared minus squared. But hold on, how many terms should he have in his answer?
3.
So get me the squared. What's y cubed times y cubed? Y to the 6th. I know it's tricky for a lot of people. Good, Melanie. Y cubed times y cubed is y to the 6th. What's double? What's double? 4y cubed. 8. Yeah. Squared double. What's 4 times 4? But if that was way too much mental work, no stress. Couldn't you have just done this? Get your table and say y cubed, that's y to the 6th if I put them all together. 4y cubed, 16. Y to the 6th plus 8y cubed plus 16. However you do it, whether it's with the shortcut or the table, find a way that works in a way that you won't mess up. Does that make sense? So what, from section 7.3, was the point? Do you know how to do this with a table or a shortcut or both? Do you know how to do this with a table or a shortcut or both? Don't mix them. Got it? Okay. You guys have a worksheet. Freshmen, most of you have finished it. Sophomores, it's kind of homework. Maybe you just finished it. Maybe you're working on it. Now pause. Hold on. Time out. Did I show a lot of work when I was doing the shortcuts?
Yes.
No.
Sometimes yes, sometimes no, depending on how hard it was, right? So tomorrow when I grade your guys' worksheets and I'm walking around, actually I'll probably have you pass them up to the front as you're taking the quiz. I'm going to grade your worksheets then. That's okay? I'm going to be looking at it, and I'm going to be looking at whether you're using tables or you're showing work or whether you're not. Now wait, if you're not showing work, what do I think you're going to have down? That means I can be calling on you. You should be popping off because the shortcut goes fast, right? But if you're like, no, please, no, not me, then show me work. And be like, I do it the other way. And I'm like, okay. Then I won't expect you to know the shortcut. Does that make sense? Okay. Now, remember, for a worksheet, can the work be in your homework spiral? Yes. Can it be on the worksheet? Yes. So however you're going to be doing these problems, if the shortcut's too intense, then show me the work, and I won't expect you to have these quickly off the top of your head. But if you're like, nah, I don't need to show work, I've got it, then I'm going to test you in class and just make sure with calling on you every now and then. Sound good? Cool. All right, let's go ahead and open up our notes. We graded homework. Freshmen, you did yesterday. You helped me out to help the sophomores grade it today. Everybody has their worksheet to work on. Everybody has the worksheet to work on. Here's what I want you guys to see today. Section 7.4. We're just going to start them. Tomorrow after the quiz, we're going to finish them. That's why numbers 3 through 20 isn't due until Monday. So we're just starting this guy today. The worksheet's the only homework that's due tomorrow. We're just starting this guy today. 7.4, you guys are doing a great job. For one reason or another, we quiet it down. Homework, oh yeah, can you guys hold up Some of you pulled away. I'm so sorry. Can you hold up homework and let me see it real fast? The one we just graded. 15 through 22, the really awkward one. I'll start on this side of it because we have it ready. So I'll come back. Got it. Got it.
Oh,
that's the first one.
yeah.
And then you get it.
Yeah, also. So what is it? The first one? I think it was absent.
I see some of you doing shortcuts and some of you. Got them.
Cheat.
Show me the end of class. Got him. Shortcut, Jeremy? Are we using it? Brooke? Skylar? Good. You guys can go in your composition book once I grade your homework and start writing 7-4 and saying, what on earth is she going to do with that? Look at that weird stuff up there. She's doing a lot of shortcuts.
Jeremy, stop learning, stop learning. Come on, man. Jeremy. Like yeah, it's her.
Check yours.
No.
Oh, because you were gone too. Got it. Okay, I have Everest makeup work, I have Andrew Swanson's makeup work, and then who was the other one that gave it to me? Andres, you gave me makeup work.
Yeah, what?
Sorry, your names weren't on it. I was making sure I got the right people.
Oh, yeah.
Kiddos, I have a question.
Yeah.
What plus 5 makes 5?
0.
Oh, that's easy.
Like that.
Like literally, that's all. Yeah.
Yeah.
Okay. 5 plus what is 0?
Negative 5.
So 5 times what is 5?
1.
And 5 times what is 0?
0.
Oh. So we know our math facts, at least these kind, really fast, right?
Yeah.
So
Yeah.
what happens when the numbers change to variables? X plus what is X?
0.
Plus.
0.
Yeah. See it? I know, it's so tricky. But X plus 0 is X, just like 5 plus 0 is 5. So X plus what is 0?
Negative X.
X times what is X?
1.
And X times what is 0? Oh. Guess which one you need to know for this section?
Those.
All of them.
All of them.
That one. Why? You get rid of that because now you can't read it.
Factor.
What does
That was tough.
I need it out of the way to get it.
Uh-oh.
Oh, now there's a random
Pistachio.
Okay. Number 8 is the most important one. Alright, you don't need to all copy him, we heard it. In my days, spaghetti, but either way. So, 7.4, solving polynomial equations in factored form. To solve, we need to find the zeros. To solve, we need to find the zeros. What does that mean? Well, let's talk about it. What does that mean? Let's talk about it. Alright, guys, focus. Ready? So far, what you really need to have down is the number and the title. That's about it. If you got the rest of it, cool. If not, it's fine. Section 7.4, solving polynomial equations in factored form. Okay, you ready? A special form of a polynomial. If you were to look at a polynomial, and if he was to look like this, which you guys have been seeing kind of in homework here or there, this is what we call factored form. This is what we call factored form. Now, this would have been like a homework problem in section, 7.2. Because in section 7.2, we learned how to multiply any binomials, not the special squared minus squared squared double squared, not the special ones. That was 7.3. But just any, because guys, these aren't special, are they?
No.
They're not the same. 2 and 3 is different. So they're the old school table arrow way, table foil way. So the other way that it could be is, does anybody see this would be x squared plus 5x plus 6?
What?
If you did the table? Well, if you did the table though. Because if you did the table, or if you did the arrows, wouldn't you get x squared plus 2x plus 3x plus 6? And what's 2x plus 3x? Yeah, so it's the condensed, once you do the table, once you do the arrows, and you put it all together, you get your 3 answers. It's not squared double squared. It's not a special one. But anyway, in section 7.2, we would have learned, or we did learn, how to multiply with a table or with arrows. See if I can get rid of this guy. Oh, he's going to be nasty. Yep. Be correct. But our factored form says, okay, it's a polynomial. It's just a polynomial written with parentheses. This other guy is just kind of like standard form. Now, this is actually called something really special called a quadratic. Can we change that, please? It's a little too distracting for you, which is why I don't have any normal. We have factored form on the left. We have standard form. Stop the extra talking, please. Everyone around you. It's not your business. Factored form. Stop. Standard form. This is a special guy called a quadratic. That's why I want you to pay attention. We talked about this the other day, right? Called a quadratic. He's a parabola. There's all the snazzy stuff that pre-calc kids and algebra 2 kids have to deal with. Maybe you'll see him later this year. But we have factored form and standard form. Now, here's the really, really cool. Well, you guys see factored form is the most important guy right now. So we're highlighting this guy on the left. Factored form says you can look at a polynomial as a multiplication of binomials. Sometimes. And what's cool about this factored form is exactly what you guys just saw on the page before. Oh, that's the wrong one. Exactly what you guys saw on the page before. If we have a factor, right, I'm going to put in parentheses. If we have a factor times a factor, we know to get 0, one of them has to be 0. Check it, the zero product property. If the product, if the multiplication, remember product means multiplication, if the product of 2 factors is 0, at least one of them must be 0. You guys knew it over here. 5 times what is 0? I had to have a 0. X times what is 0? I had to have a 0. All this says is, I have to have a 0. Which means one of these must be 0. Which means one of those must be 0. You guys need to fill in this blank with a 0. You need to fill in this blank with a 0. You know this property without even you having to write it down. It just is going to look funny once we're using it with polynomials. Well, maybe and maybe not. Do you guys see how this is supposed to equal 0? See it? There's a 0. And what's over here is a multiplication of one thing, one term, by another term. A monomial times a binomial. Now, that's not supposed to be super stressful. All I need you to know, Jeremy, is that in order to multiply to be 0, one of them has to be 0. Who? Either one. So here's the dealio. If we're trying to solve this guy, and if 0 is on one side, and if we have factored form already, which means parentheses, they're looking like a multiplication instead of an addition. They're looking like multiplication instead of addition. All I have to do is set each one equal to 0 and solve. That's it. So check it. Is one side equal to 0 in this problem? Yeah, I got a 0. Okay, that one's a check. Do I have factored form? Is this written as parentheses, not standard?
Yes.
Yes. Check. Split up the factors. What does that mean? Split up the parentheses. So 2x goes one direction. He goes his way. And x minus 4, well, he goes his. They go opposite directions. And check it. Split them up and do what? Set each equal to 0. It's as easy as that. Make sure one side is 0. See that it's in factored form. Split them up. Set each one equal to 0. Well, what am I left with doing? Okay, well, how do I solve for x, guys, if I have 2x equals 0? What do I do to both sides? Divide by 2 over 2 is just 1x. And then what's 0 divided by anything? 0. There's one answer. X minus 4 equals 0. How do I get x alone? Add 4. X equals, guess how many answers I have? 2. Dun, 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 dun. That's it. That's it. In order to make a 0, one of them has to be 0. So wait, check out this entire page of example problems. Now guys, this is kind of like 3 through 20, due Monday, but we're going to spend a little more time after the quiz tomorrow. What are we going to do for every single one? Make sure one side is 0. Is that true? Got him. Then what? Make sure they're written as factors. Do you guys see multiplications in all of them?
Yeah.
I see multiplications, don't you?
I do.
So what are we going to do for set number 3?
Split them.
Like God in the Red Sea. Split it. Right? Put x. We'll put x minus 1. Well, I think God is the one that did it, but you're right. Through Moses. Good job.
Yeah.
What do I do to each one? He's right, though, right? Moses did that. What do I do once they're split? What do I do once they're split?
Solve it.
Not yet, not yet.
0.
Equals 0. Then solve. I see it, I split it, I solve it. Bye, guys. For tomorrow, 7-1-7-2-7-3. Look over those homeworks. 7-1-7-2-7-3. Look over those homeworks. The worksheet will help you practice. Bye, guys.
Right.